Okay, just to keep going with the examples, more of the examples for the points of discontinuity and stuff like that. Oops, I've got yellow going on, which is gross. Whoops. There. Okay, another example here. This one here, now, I've never seen it on the exam, but I think it's quite important because of how we deal with it in grade 11. You know, when we're talking about the horizontal asymptotes, and we say the rules where, you know, if the degree in the numerator is less than the denominator, it's 0. If they're equal, it's a over b. Those two kind of stand true. But when we say that if the degree in the numerator is higher than the degree in the denominator, that's not necessarily true. Because we would always say, oh, there isn't one, right? Not exactly, okay? And I'll show you an example. Let's go f of x equals x squared plus 2x plus 1 over, let's just make it easy and let's say x. So, in grade 11, we'd say if the degree in the top is bigger than the degree in the bottom, like this example, our reasoning for the horizontal asymptote was there isn't one, right? And we'd drop it. We just wouldn't draw it. And sometimes the graphs would work out kind of funny and be like, well, how can that be? Well, that's true if the degree is more than 1 degree higher. Okay? So right now, when I look at these numbers here, the degree here is a 2. The degree here is a 1. So it's only 1 bigger. That means there is an asymptote, but it's not a horizontal asymptote. It's an oblique asymptote. So let's put that down. Let's go like this. Put a star and say if your exponent on the top is 1 bigger, 1 degree bigger, or 1 degree larger, you will have an oblique asymptote. I'll show you what that means right away. So an asymptote. So in order to do that, we've got to long divide polynomials again. Woo! Yay! Everybody's favorite. Okay. So an oblique is pretty simple. It's going to be a straight line, like a linear equation. So it's just a line that's on an angle, not horizontal. So we'd always say, oh, there is no horizontal asymptote. That's true, but in grade 11, we just ignored it then, right? When really, there is an asymptote, but it's on an angle. So let's go and do this one here. We should factor it first, right? So that we can see some stuff. So we'll just carry the example down here. F of x equals x plus 1 over x. Okay, so yay, all done. But for our asymptote, I've got a long divide. Okay, and I say long divide because we haven't learned synthetic division yet. Pretty nice and easy. It's a monomial, right? So nothing's huge here. So x squared, I'm going to divide my leading term. So x squared divided by x is x. I'm going to multiply that back down so I get x squared. When I subtract that, that's gone. So I'm going to bring down the 2x. 2x now divided by x is 2 plus 2. Multiply that down, I get 2x. Bring down the 1. Right, whoops. I got to subtract and bring down the 1. So 1, my bad there. So you get the 1, or yeah. So now, this here, guys, is a remainder, right? When we deal with oblique asymptotes, you ignore the remainder. Okay? Ignore remainders. Now, I'm not going to ever expect you to do this. I'm showing you this in case somebody somewhere ever decides to give you a question like this, okay? Oblique asymptotes are not expected of you, but if they do, you know what to do now, okay? Here, I'll circle it in red here for you. This, guys, is the equation of your asymptote. That's your asymptote right there. Okay? So when I go and graph this, you'll see. Everybody's got that? So I'm going to change the page here. Okay, so we had f of x equals x plus 1 over x. That was what we were at. So we know we've got vertical asymptote at 0, just from the denominator. I've got an oblique asymptote at x as an equation of x plus 2, right? Y equals x plus 2. We've got x-intercepts, or an x-intercept of x equals -1, good. Y-intercept, what's our y-intercept going to be? We're going to have one? If we plug 0 into our x's, we're dividing by 0, right? Something goofy's gone on because of vertical asymptote, right? Okay, so let's go and graph this now. So I'll just go and make a little graph. Okay. You notice we don't have any holes on this one, eh? Let's go use red. I like red. Okay, vertical asymptote at x equals 0. There's our vertical asymptote. We don't have a horizontal asymptote. We have an oblique one. And it's the equation of x plus 2. So I literally graph this like I'm graphing a linear equation in grade 9. So my y-intercept at 2, a slope of 1, so I go up 1, over 1. And there is my oblique asymptote. So the graph exists somewhere in those quadrants. I'll call them quadrants. They're not really quadrants, but you can see what's going to happen now. Okay, let's... Yeah, exactly. It's just y equals mx plus b, and you get this weird looking... Wow, it's kind of cool, actually. Yeah, you'll see. We you know as well as anybody, we just sketch the graph, so we're not graphing it with great detail here, but you'll see what happens. So we've got an x-intercept at x equals -1. So right there. So I already know what that graph's going to do, don't I? What's it going to do? You better say follow the asymptotes to infinity, right? Because that's what asymptotes are. So it's going to go like this. And it might go up in there a little bit, who knows. But it's going to go like that. And of course, I should have an idea where the other part is. But because we have never done this, we'll do a quick little table of values. I'll change the table of values to blue. So x and y. And all we need is 1 point, right? So what value do you want to plug in for x? 2? So let's plug in a 2. X equals 2. I plug in an x equals 2. You're going to get 4 plus 4 is 8 plus 1 is 9 over 2. So you get 9 halves. Right? 4 1/2. So at 2, I'm going all the way up to 4 1/2. Like I said, we probably didn't need to do a table of values because we should know that it kind of does the same thing with all of our... Well, you've got the 4 1/2 or 9 halves, so, you know. Yeah, if you'd want it to be accurate. Yeah. At least you'd want 2 or 3 points, you know. So you can see how oblique asymptotes work. Not that bad. No? Anybody else? So long divide to get the oblique asymptote. Like I said, I don't think I would ever give you a question like that. By accident I would, you know. But let's pretend I wouldn't do that. So let's do an example off your assignments. I've given you your assignment booklet, so somebody just look for what you think the ugliest one that you can find is. Let's see. 16 is nice and ugly. You want to do a cube root one? 11, here we go. So f of x equals negative x cubed minus 2x squared over x cubed minus x squared minus 6x. And you'll notice the instructions are to identify the points of discontinuity, which are holes, vertical asymptotes, all that stuff. X-intercepts, horizontal asymptotes, and the domain of each. Okay, you've got to start doing, whenever we graph, think domain, think domain, think domain. Okay, because it kind of rules the world. All right. So, back to grade 11. We're going to factor. We've got to cancel if we can. Okay, because if we cancel, what have we created? A hole. Okay, so f of x equals, oh, just a word of advice. You see how I put the f of x now? A bad habit of mine is not to put it, but if you didn't put that on your exam, you're going to lose a communication error. No, like if you just drop it, a lot of people do, and if you change it to y, that's fine if you state f of x equals y, right? That's okay. But if you just drop it and do what I would normally just factor and cancel. Okay, let's take out a negative x squared upstairs. When I do that, I'm left with x plus 2. Oh, that's beautiful. In the bottom, I'm going to take out an x. That's going to leave me with x squared minus x minus 6. Yeah, we got it. Yeah, that's now trinomial, so we got to go further. So we'll just write everything down again. Negative x squared x plus 2 over an x. Factor that, x minus 3 x plus 2. Alrighty. Can we cancel some stuff? What can I cancel? X plus 2, is that it? Yeah. Yeah. We've got an x here and an x there, I'll call it. So now, I know I've got holes at x equals negative 2 and 0. Right? Well, because remember we canceled the x, so that's a factor as well, right? Yeah. So let's maybe take this a bit further now. So f of x equals negative x over x minus 3. Because we've got to state all of our other stuff still, right? Vertical asymptote. X equals 3. X intercepts. Y intercepts. X intercept is? Do we really have an x intercept? Why? We'll put it down here first and you'll see. X intercept will put as x equals 0 because of this right there, right? But we'll see what happens when we graph this thing. From the top, right? Factor and solve. Our y-intercept. What's the y-intercept going to be? 0. Yep. Again, we'll see what this ends up coming. We're just plugging in our numbers, right? So y-intercept, we plug x 0 into everything, right? Well, 0 divided by anything is 0, right? When we find our x-intercepts, y is equal to 0, or in this case, the whole f of x is 0. Multiply that up, x equals 0. So that's all there. Was there anything else we were asked for? We were asked for points of discontinuity. We got those. X-intercept, Y-intercept. Were we asked for range? Domain, yeah. We'll get the domain after we graph it. Okay? So I think we're okay to start graphing this now. Right? Let's go see what it looks like. So, oops. I'll put the function again up here. F of x, we had negative x over x plus 3, right? Okay. Now, we've got some asymptotes at x equals. Those aren't asymptotes. Right, at x equals 3 was our asymptote? Or was it negative 3? Negative 3, wasn't it? Oh, is this an x minus 3 up here? Oh, sorry, guys. We'll change that to a minus 3. My bad. Okay. So, here we go with our asymptote then. There's the asymptote. Do we have a horizontal asymptote in this one? We never did write that down. What was the horizontal asymptote? Remember the rules. If the degree is the same, it's a over b. Negative 1. So horizontal asymptote at negative 1. So down here at negative 1, we've got a horizontal asymptote. We've got x-intercept, y-intercept at 0. So do I need more for that graph, or do I know where it's going? It's going to follow the asymptote, right? It's going to go like so and head up. Now, over here, how can I find what this side of the graph looks like? Yeah, I can do a quick table of value. So x, y. Plug in, I don't know, x equals 4 makes sense. So negative 4 over negative 7 is positive 4/7. Right? Oh, sorry, negative 4 over 1. My bad. So negative 4 over 1 is negative 4. 2, 3, 4. So down here. Again, I shouldn't need much other than this. Are we done? Holes, right? So we have holes at x equals negative 2. So over 1, 2. So I have a hole right there. And where else? 0. Well, that's the quandary with holes, right? It's confusion, okay? But we've got those situations, and what I'll do is I'll show you the actual like graph. Like we'll pull it up and we'll graph it so you can see technology and what happens when we do that, okay? But by hand, that looks pretty good, right? So there's nothing really to it other than graphing, finding your asymptotes, which you already know how to do. Those holes are simple. X and Y intercepts are simple. Plot everything, graph it. If you don't have enough information though, make sure you do this. A little table of values. Get another point or two. It doesn't hurt. Okay? Are there any questions? Yeah, well, pretty close.